Welcome to Summarize Science, where we break down the latest research. When we imagine rocky exoplanets, we usually picture worlds built like Earth, but is that always the case? A new study suggests a planet's fundamental makeup might be decided by where in the galaxy it was born. The central idea is that planets and stars form from the same cloud of gas and dust, so their chemistry should be linked. To test this, researchers investigated the connection between the density of small, rocky planets and the chemical elements found in their host stars. They gathered detailed chemical data for the host stars of 22 different rocky planets, including both sun-like stars and smaller M-dwarfs. This allowed them to see how these planetary systems fit into the bigger picture of our Milky Way's chemical history. Stars in different parts of the galaxy, like the older thick disk versus the younger thin disk, where we are, have different chemical makeups. And here is the incredible result. The scientists discovered a strong, inverse relationship between a planet's density and its host star's ratio of magnesium to iron, or Mg/Fe. Simply put, the more iron a star has compared to magnesium, the denser its planets are. Conversely, stars richer in magnesium have planets that are significantly less dense. What does this actually mean for the planets themselves? If we assume these planets have Earth-like structures, this suggests that in iron-rich environments, planets form with larger, denser iron cores. In magnesium-rich environments, like the galaxy's older thick disk, planets form with smaller cores and larger, less dense silicate mantles. This trend holds true even when including planets around M-dwarf stars, which are the most common stars in the galaxy. Interestingly, the 4 M-dwarf planets in the study all had lower densities, helping to strengthen the correlation. This suggests that a planet's galactic zip code and the time it was formed play a huge role in its final composition. So, let's recap the important points. This study provides strong evidence that a rocky planet's density is directly linked to the magnesium-to-iron ratio of its parent star. This implies that a planet's internal structure, like the size of its core, is not random, but is instead determined by the chemical environment of its birthplace in the galaxy. The planet TI 561b, a known resident of the ancient thick disk, is a key piece of evidence, having a high magnesium-to-iron ratio and a very low density. This fundamentally changes how we think about Earth-like worlds. It means that rocky planets across the galaxy could have a wide variety of core sizes and mantle compositions. Future studies with larger samples of planets, especially from the galaxy's older regions, will be crucial to confirming just how deep this connection between planets and galactic evolution goes.